Hello, everybody. Welcome back. It's nice to see you all. I think we have one or two new people this evening as well. And we got lots of questions. People sent in lots of questions. So we're going to be busy. I hope we get through all of them. As people are joining and we're waiting for everyone just to enter, you can start having a look at the question that's up on the screen, question 2, given the arithmetic series, etc. Have a look at that question and start working at it. And in a little while, we will start going through the answer. These questions were sent in by Caitlin. Thanks for that, Caitlin. And we've got questions we've got another one from Timothy, another 2 from Timothy, and Asipe also sent us his questions. So great. That is really great, guys. Let's have a look so long. Seems like we are all just busy with paper 1 at the moment. Just trying to get this one out the way, I guess. Maybe next week we'll start tackling paper 2 stuff. Remember, if you want your question answered, you can send it to me via email or via the app. I will get it, hopefully in time before the lesson. Is anyone writing their exam tomorrow? Just put it in the chat if you are writing your exam tomorrow. Anyone writing on Friday? I think there were a few who said they were writing on Friday. Who's writing on Friday? Zwelichle. How do you feel? Are you feeling strong? Benedict, you as well. And Silindile, okay. Friday. And Jaden. And how are you guys feeling? Are you feeling strong? Do you still feel like you need to do a bit of work? Hi, Asipe. Stressed out. It's just maths. It's going to be fine, Benedict. A lot of work. It is. It's definitely up there as one of the subjects with the most work. Yes, there is still some time to do more, Jaden. That's true. Can't afford to sleep. No, Timothy, you must sleep. The tired brain can't think. Okay. It is a lot, yeah. But you'll get through it. You will get through it. And just remember, there's finals still, so it's all okay. It's all going to be fine, guys. Okay, so let's see. Here we've got a question. This was Caitlin's question. This comes from, I hunted it down. It says there DBE 2016. I think it is the, what's it called? The supplementary exam from 2016. That's where this question comes from. And often it's a good idea to do those supplementary exams. They've got some interesting questions in them. I don't know if it's the same people setting all the exams. Sometimes it feels to me like it's just different people setting different exams. But I would like to know who these people are and where they get their questions from. And if they sit in a dark room and just think of maths questions the whole day. Okay, so here we have an arithmetic series. Asked in a little bit of a different way because A is missing and B is missing. So we can't tell straight away what the constant difference is. But what you can do is say, well, each time it will be the same. So between whatever you add each time, it will be the same number because it's an arithmetic sequence or an arithmetic series. So whatever you add, so if you take 13 and 27, and between 13 and 27, you would have added two lots of constant differences, right? So because you would have added it to get B, and then you would have added it to get 27. So you would have, whatever that number is, you would have added it twice. So you can say, what is the difference between 13 and 27? So that is 14. And then divide that by 2, which gives you 7. So 27 minus 13, that's the difference between the two terms. That's 14. Divide by 2 gives me 7. That will mean if I subtract 7 from 13, I get 6. And if I add 7 to 13, I'll get 20. That is why A is 6 and B is 20. Okay, how's that? Does that make sense? Can I see some emojis, please, if you're with me, guys? Excellent. Thanks, Rekhmuditso. Caitlin, good stuff. Okay. Now, this is what I wanted to say. When it is a show question, show means show us, do some working out to get to that answer. You can never start your question with that, okay? You have to show, meaning do some calculation and arrive at this answer. It's a bit of a, like a, I don't know, almost like doesn't make a lot of sense because it's like, here's the answer, show us how you got there, okay? So to avoid, do you guys know what a breakdown is? No, not like the breakdown you get the night before your exam, hopefully. But what is a breakdown when you are writing your paper and someone's marking it? Does anyone know what a breakdown is? So a breakdown, okay. So a breakdown is something that you must avoid, okay? Obviously, when we write exams, you know, you want to avoid breaking down. But when you are writing your paper and you're giving answers, then it's when you do something completely wrong and there's no partial marks or anything. That is a breakdown. Now, in this case, it would have been a breakdown if you just wrote down maybe your A is 6 and then you plugged it in to your series. Maybe you said, okay, so A is 6 and now I know that that is, the difference is 7, and now I know because of that, now I can say B is 20. Okay, so if you started with that, that would have been a breakdown, meaning you would get absolutely no marks. Okay, so as we go through, I'll try and point out some more more places where things can result in a breakdown. Okay, so here's a good example as well, 2.1.2. Calculate the sum of the first 20 terms of the series. So say you use the geometric formula to calculate the sum of this arithmetic series. That's a breakdown as well. You get no marks for it. Absolutely no marks. Okay. Also, two mistakes in a row, that's a breakdown as well. So even if you start something and you make a mistake and then you make another mistake, like they're not going to carry on marking after that. That's also considered a breakdown. Okay, so I'm glad you guys learned about breakdowns today because that is really important for getting as many marks as you can. Right, so we have to calculate the sum of the first 20 terms of the series. So we use our sum formula. This, you go straight to your formula sheet. This is on your formula sheet that you get handed. Okay, so there's no reason to get the formula wrong. Okay, I didn't write out the first part of the formula completely because I wanted to save some time, but this is the formula for the sum of an arithmetic series. So you sub in 20 because we are adding 20 terms together. 20 divided by 2, that's just part of the formula. 2 times A is 6. We worked it out. Over here, A is 6. And then 20 minus 1, also part of the formula, times by 7. 7 is your constant difference. Calculator work 1,450. Okay, so this is a 3-mark question that is definitely a routine question, meaning this is like money in the bag. Okay, you've got to get this right. This is something that you have to know how to do. And maybe as we go through tonight, through the questions tonight, also check which ones are the routine ones. And if you are struggling to pass, or if you are just wanting to get to your 50% or your 40%, really, really work on the routine questions, the questions that will be in the paper no matter what, and just practice those before you get to like all the hard stuff that becomes a bit scary sometimes. Now, what if here's another tip. What if you got stuck on 2.1.1 and you couldn't show that A is 6 and B is 20? Then carry on, do 2.1.2 as if you could answer the question, okay? Because if you know that A is 6 and that B is 20, then you can still carry on and do the rest. You can still do 2.1.2 and get those 3 marks, and then 2.1.3 hopefully as well. So even if somehow you just didn't click how to do 2.1.1, use those answers to answer the next question. They're right there, okay? You can see what A is, and you can see what B is. You can use it to answer the next question. No need to stop, okay? You really got to find all the marks that you can. Okay, so write the series in sigma notation. Okay, so now sigma notation, we just have to bold it. Okay, so we start, I'm actually going to start this from scratch so that we can build it nicely. Okay, so you make your sigma sign. Sigma notation always means sum. Sum from which term? From where n is equal to what? Well, we are summing 20 terms, so we're going to start with the first term, the second term, the third term, the fourth term, and go all the way up to the 20th term. So where do we start? We start at the first term. We go up to where? The 20th term. So that is n equal to 20. N is the number of terms that you are summing together. Now, here in this part of the sigma, you have to write down the general term, okay? The general term for this sequence. What is the general term? Well, it is an arithmetic sequence. So when we do arithmetic sequence, it's Tn is A plus n minus 1d. A for this sequence we said was 6. N minus 1, n is the number of terms we're adding, so it's, no, we're not going to do n minus 1, sorry, we're going to leave it as general, and then the difference is 7. And if we simplify this, then we're going to get what I got over here, 7n minus 1. So that is 6 plus 7n minus 7 simplifies to 7n minus 1. Okay, so here's the final answer. So where do I start? With n equal to 1, I go up to n equal to 20, and in this space over here, you put your general term. General term for the sequence. And whenever you are writing a sum of a series as sigma notation, that is exactly the thought process. Where do I start? Where do I end? What is my general term? And those are the three little building blocks of your sigma that you have to put together. How are we doing so far? How are we doing with the sigma? Please ask a question, guys. Friday is coming closer. Do we have any questions about sigma, or are we all good? No questions. Okay, excellent. Now let's have a look at our next question, which was this. Here's a geometric sequence or a geometric series. Determine the values of x for which the series converges. Okay, so I would say question 2.1.3 was also a routine question, because you just have to build your sigma. You have to know how to do that. Okay, that is like not anything funny. You have to know how to write something in sigma notation. Now, 2.2, given the geometric sequence. Now, I would say this isn't 100% straightforward. We are moving into the realm of complex. Okay, so this question is slightly more complex. What makes it complex is because we've got variables, not a straightforward series with numbers. So I would say this question is definitely on the complex side. And there's some work you have to do before you can answer this actual question. It says, determine the values of x for which the series converges. Okay, so series converges. There's a few things that need to go off in your head when you think about converging series. Only happens for geometric series. That series converge. And for that, our constant ratio has to be between -1 and 1. Okay, also something you have to know. For convergent geometric series, the constant ratio is between -1 and 1. Okay, if you're writing notes, you should make these either a one-page summary of each section or little note cards that I call the no-brainer cards, because these are the no-brainer things that you must know. Like, if I wake you in the middle of the night and say, for what values of R does a geometric series converge? And you have to say, if R is between -1 and 1. Okay, that's how well you have to know. Anyway, so first we have to figure out what our R is, right? This is a geometric series. What is our R? And I'm going to pause here for a bit so that you can think about this and see how you're going to work it out. Just going to give you a minute or two to see if you can figure out what is going on with the series and what our R is. Our R is not going to be a number. It is going to be variables and numbers. It's going to be in terms of x. Okay, can anyone tell me what the constant ratio is, what our R is for this sequence? What did I multiply x minus 2 by to get x squared minus 4, and then to get this whole long x cubed plus 2x squared minus 4x minus 8? What did I multiply by? What is R? Does anyone know? X plus 2, great stuff. Yes, CP, I agree with that. there you go. X minus 2 times x plus 2 will give you x squared minus 4. And then if you check, x squared minus 4 times x plus 2 will give you that whole long polynomial there. So that's the first thing. So our r is x plus 2. Now we have to check for what values it will converge. So we take our x plus 2. So I just want to go back to the question. Determine the values of x for which the series converges. Here we go. So we take our x plus 2 and we place it into that inequality because r is x plus 2. Now I need to get x by itself, just like I would with a normal equation. So I subtract 2. If I subtract 2 in the middle, I must subtract 2 on the right-hand side, and I must subtract 2 on the left-hand side. So x is going to be between -3 and -1. Okay, questions about that? Everyone okay with that? Can I just see a thumbs up or a thumbs down? Thumbs up.
Ma'am?
Yes.
I do understand this question, but it's kind of not related. But I want to know, when does like the inequality sign change? Like when we are doing calculations, when does it change?
Okay, so inequality signs only change direction when you are adding or multiplying with a negative number. So say I had something like negative x is smaller than 1. Okay, so we don't do negative x, we just want x, so we're going to multiply by negative. So that will make it x is greater than -1.
Oh, okay, ma'am, I get it. Thank you.
And say it was like this, -1 and not -2, just 2. So say we had a double inequality like this one, and we needed to make x in the middle positive, and we still times by the -1 and times by the -1, times by -1, but now everything has to change. Okay, now the thing with inequality signs is they're always chasing each other, okay? They go like this,
Yes, ma'am.
like Pac-Man, and they go like that. They never go like this, okay? They're never swimming towards each other. They're always going in the same direction, like T-Rex hands, okay?
Yes, ma'am.
Okay, so it would be like that. So if you swap the one, you must swap the other one as well. So always going in the same direction.
Okay, ma'am. Thank you.
It's a good question, because with this converging series thing, it sometimes happens that you have to change them around. Okay, right. So 2.2, if x is now -3/2, calculate the sum to infinity of the given series. Okay, so if x is -3/2, we are going to substitute that into here. So even if maybe now we get again to like exam savvy and exam mindset, even if you couldn't do 2.2.1, you can most certainly do 2.2.2, because all you have to do is make x -3/2 to see what a is. A is your first term. So then your first term is -3/2 minus 2. So that is -7/2. And then you can either use your r that you got here as x plus 2 and substitute that in, or you could have gone the long way and worked out what each term was by subbing in x and then worked out your r. Either way, you'll get that r as a half, and then you use your sum to infinity formula on your formula sheet. So you just look for it. It's a over 1 minus r. Sub in, calculator, minus 7. Okay, but matrix, to get all 4 your marks, 3 marks. Okay, so you get for calculating r correctly, calculating a, then for subbing into the correct formula, and then for final answer. Okay, so make sure you show the substitution step. Don't just write final answer. Okay, I hope you're taking note of some of the tips I'm giving you so that you get all of your marks, not just some of them. And also how to get some marks if you don't think you can get all of them. So that is definitely also a routine question. You could just sub in for x and then do sum to infinity using your formula. Okay, so that was Caitlin's first question. Thanks so much for that, Caitlin. I think that covered some good stuff, some sigma, geometric series, converging, etc. The next one you submitted is a graph question. Okay, everyone have a read and a look so long. I always like to do this when there's more than one graph. Just make them different colors. Sometimes it helps to make things a bit easier. So you've got some highlighters, maybe put them into different colors. Okay, let's see. Write down the coordinates. So first of all, we've got a parabola, minus x squared minus 2x plus 3, and a straight line for which there's no equation given. So the graph of graph F has x-intercepts at A and B is 1 and 0. So don't ever leave out or forget to read the stuff that's written down, because already here is a point on this graph that's not shown here that is, I think, going to be quite important to us, this point here. Okay, so always read what it says because it contains important information. The straight line G passing through A and C cuts the y-axis at E. Okay. Write down the coordinates of the y-intercept of F. Can we all do that? What is the y-intercept of F? A 1 marker. Can we do that? Put it in the chat if you know. Okay. CJ, you said 0 and 3. Can you tell us how you know that it's 0 and 3? It is the right answer. Just tell us how you know that. You can just unmute yourself, CJ. Or Asipe, can you help us? You also wrote down the right answer. How do we know that that is the y-intercept? You substitute 0 into x. Okay. Quicker way. It's a 1-mark question. What is the quickest way to know that? Asipe, do you know? That definitely works, CJ. There is a quicker way. Asibe, can you help? Can anyone else help? Okay. What about this number here in the equation of the parabola? That is the y-intercept of the parabola. So it has to go through this point 0 and 3 over here. You can just read it off the equation. Thanks, Daneo. Yeah, value of c in the formula is 3. It's okay, Jaden. Welcome, Atinkosi. I'm glad you can make it. Okay, everybody, that's the quickest way. The value of c, that constant value in the parabola, is 3. Okay, so that is definitely routine. That is routine that you must know. Okay, show that the coordinates of c are -1 and 4. Now here's that show again. Show that. So show us how you get to this answer. Show us how the coordinates of c are -1 and 4. So what is special about c? This point here. What did we read about it over here? It is the turning point. So how do we calculate the turning point of a parabola, which is what this question is actually asking us for? How do we calculate the turning point of a parabola? Minus b over 2a. That gives us the x coordinates. That's right. And once we have the x, we can find the y. So x is minus b over 2a. And I'm using my parabola equation. So minus b is minus 2. And 2a is minus 1. Sorry, I keep moving up and down, but just need to see the question. So that is 2 over -2 gives me -1. And now you should start smiling because you're getting what they're asking for. Over there, they asked for the x coordinate to be -1. You've now shown how to get x equal to -1. Now you have to show how to get y equal to 4. So we're going to sub x equal to -1. We're going to sub it into our parabola. Minus and then y, I bet, is 4. So that's -1 plus 3 plus 2 plus 3 is 4. Therefore, c is -1 and 4. Okay. Turning point of the parabola is another one of those no-brainer things. You have to know how to do that. X is minus b over 2a, and then sub in to get y. The other way to do it is to complete the square, but that can get messy. So the easiest and quickest way is to just do the formula. Okay, so this is -1 and 4. Okay. Good. So where are we with 4.3? Write down the coordinates of A. So what is A? How will we find A? The coordinates of A. Any ideas? You say it's -3 and 0. Jaden, how did you get that? It's a 1 mark question, so it's got to be something quick, right? How did you get that, Jaden? Can you tell us? Yes, you can make y equal to 0 and then solve. That's right. So we could go take our equation minus x squared minus 2x plus 3. And then we factorize that. I'm just going to get rid of this minus in front of this x squared. So that's 2x minus 3. And then we go x plus 3x minus 1. So then x is minus 3 or x is 1. That's option 1, to do it that way. Option 2 is to use the symmetry of the parabola. Because in the previous question, we just found the turning point. So this is where the axis of symmetry of the parabola goes through. So if this is -1 and this distance is 2, then because of the symmetry of the parabola, this distance must also be 2, which will get me to -3. Okay, so that's using the symmetry of the parabola. Okay. That's the quickest way. And if you just went straight to answer for 1 mark, you can do that. That will be fine. Okay, so these are all still routine. Now we have to calculate the length of CE. 6 marks, okay. What are we going to do here? The length of CE. We got the coordinates of C. Can we find the coordinates of E? It's going to be a bit of work. I think what we should do is find the, if we look at E, let's start there. That is the y-intercept of this straight line that I made green. We don't have the equation of the straight line, but we can find the equation of the straight line. We've got 2 points, 2 points on the straight line, which is A and C. That's enough information to calculate a gradient and to calculate what C is. So let's start there. We're going to find the equation of y equals mx plus c. And we start with the gradient. The gradient is y2 minus y1 over x2 minus x1. The coordinates that I'm going to use is going to be A and C. So A is -3 and 0. Just going to write them down over here. And C was -1 and 4. So we use those to calculate the gradient. And we can go 0 minus 4 over -3 minus -1. Minus 2. So that is 2. Gradient is 2. Now that we have the gradient, we're halfway there. Since we have the gradient, we can just take one of those points, C or A, and sub into this equation to solve for C. So I'm going to take A, -3 and 0. That's 0. And that gives me -6 plus C, and then C is 6. Okay, does it all make sense with our graph? Looks like it. Okay, so this point here is the y-intercept. We just calculated it. It must be 6. So the coordinates here are 6 and 0. Now we have to calculate the length. This is connecting, so I'm going to definitely call this a complex question, not quite problem solving because it's not that bad, but to calculate the length, we have to do distance formula. So it is combining lots of things, which makes it a complex question. So x2 minus x1 squared plus y2 minus y1. Okay, I couldn't have done this yet without first figuring out what the y-intercept was and what c was. But we know what c was. It's like a few questions back already. So we're going to do 6 and 0. I'm just writing it here so I don't forget it. So that is the coordinates at E. And here's C. Here's E. So the distance of CE is going to be the square root. You just sub in. And you get your trustworthy calculator out to work out what that is. That's 7 squared 49 plus 16. So the square root of 49 plus 16 is the square root of 65. Okay, Caitlin, this was your question. So just let me know if there's something more that I need to explain. Okay, now that was complex. I would call this last one problem solving. So up to this point, definitely should have gotten the first 3 right. And then the last 2 are a bit, require a bit more thinking. So it says determine the value of k if h of x is 2x plus k, and it's a tangent to the graph of f. So this, you're going to need a bit of calculus as well to answer this question. Now, when it's a tangent, what happens when a line is tangent to a graph? It means that at that point, the gradient is the same. So I started the question here also just to save some time this evening. So first, we find the derivative of the parabola. And that's what I did here in this first step. That is the derivative of the parabola. So you differentiate, you get that. Now, they tell us that the gradient of the tangent is 2, meaning that where it's tangent, the parabola's gradient and this tangent's gradient must be the same. So remember, your derivative is just the instantaneous gradient. Derivative and gradient is the same thing, okay? So the parabola's gradient, which is given by minus 2x minus 2, is the same, is equal to 2, which is the gradient of that straight line. They gave it to us here, 2x plus k. I solve for x. X is negative 2. What does this tell us? This says where x is equal to negative 2, the parabola and this straight line, 2x plus k, they touch. Okay, that's where the point of, I think it's called the tangential point is. Okay, that's where they touch at x equal to negative 2, because that's where the two gradients are the same. That's where the gradient of the parabola is 2, which is the same as that straight line. Then I sub that into my parabola to get, and that's what I did over here. F of minus 2 means sub in x equal to negative 2. And then we're almost done. We get that it's 3. And then we take that equation of that straight line 2x plus k, and we sub in that point. This is the tangent point. And then we solve for k is equal to 7. Now, it's always better when you can actually see it. And it literally means that there's a straight line and it's got a gradient of 2 and it touches the graph at a certain point. And all we're basically doing is finding the equation of that line. That's what this whole story here is actually asking for. What is the equation? They've given us the gradient already. We must just find the rest of the equation. Okay, any questions about that? Because that was quite a mouthful. Caitlin, that's the end of your questions. How do you find, what do you think? How do you feel? These were your 2 questions. Really good questions. Thanks for that. How do you feel? Feel a bit better. And 6 the y at 4.4. Did I make a mistake? I did make a mistake. Ooh, thanks for that. Yeah. I had them the wrong way around. Okay, sorry, let me fix this quickly. Well spotted. 0 and 6. Who spotted it? Jaden and CJ. Yes. We should have like a system for when I make mistakes that I owe you chocolate or something. y2 minus y1 squared. Okay, that's 0 and 6. Okay. So it's minus 1 minus 0 squared. Yeah, 0 minus 1. Let me not mess it up again. And then 6 minus 4 squared. And then that's 1 plus 2 squared is 4. Yeah, 1 squared, and that's 2 squared is 4, and that's root 5. Is that better? Do you agree now? CJ, Jaden, did I do this right now? Root 5. I hope that's better. Okay, please repeat 4.5 one more time. Okay. Let's go back. Let's read the question. So the question says, determine the value of k if h of x is 2x plus k is a tangent to the graph of f. Okay, so they give us, there's this line, it's a straight line. We can see it's a straight line because it's 2x plus k. And it's tangent to f. So basically, they want the equation of that graph because we have to determine what k is. K is just basically the y-intercept of that line, right? It's in the same place as what the y-intercept normally is. So they've just called it k. Now, where do we start? Because it's tangent to that graph, we have to first figure out what the point is where it is tangent. So we start off by finding the derivative. That's this first bit here, f of x. So the equation that I'm differentiating, so f of x is minus x squared. What was it again? Minus 2x plus 3. Okay, so if you've been studying and you know your calculus and your differentiation, then you'll differentiate by going 2 times minus 1 is minus 2x and subtract a 1. So it's minus 2 to the x power of 1. And then this will be minus 2 and 3 if you differentiate to 0. Okay, why do we do that? Because the derivative, this now gives me the derivative. So anywhere on that parabola, I can use this minus 2x minus 2 to determine the gradient at any specific point on the parabola. Now, this graph is tangent at, and when it is tangent to the parabola, the gradient is 2. That is why I can then take the gradient, the derivative of the parabola, minus 2x minus 2, and put it equal to 2. The 2 comes from that line that they gave us, h of x is 2x plus k. That's where the 2 comes from. So the thing that you have to understand is that when it's tangent, the gradients are the same. The derivative of the parabola is going to be the same as the gradient of the straight line. That's why we put it together. And when we solve for x there, this gives me the x coordinate where the two graphs touch. Why do I need that x coordinate? So that I can find that coordinate point so that I can find the equation of this tangent line. So once you have the x coordinate, you sub it into the parabola. So here we put it back into the parabola so that we can find what the y coordinate is, and that's 3. And then our last step is to take that point, that minus 2 and 3, the coordinates that we just found, put it into this equation that we're looking for. H of x is 2x plus k, and solve for k. That gives you k equal to 7. Okay, it is a long question and it requires a bit of thinking, but the key to unlocking the puzzle is here with the derivative, and the fact that the tangent and the parabola must have the same gradient at the point where they touch. Okay, we're almost out of time, and we still have these questions left. This is a CPS question. Okay, let's see. This was from 2019, I think. Okay, also problem-solving question. Both of these are problem-solving. And they're 3 marks, problem-solving. And I think this one was also 3 marks. And they were in question 1, so it's part of the algebra part. Okay, so it says, I had to really think about this one. Consider the product 1 times 2 times 3 times 4 times, blah, 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 times 30. So all the way up to 30. It carries on like that. Okay, CJ, let's just quickly go back so that we can all be on the same page with the gradient of the tangent. The gradient of the tangent is given. It's given as 2. Is that okay, CJ? It comes from this equation here that I underlined in purple. It says that h of x is a tangent to that graph. So the 2 is in front of the x, and that's the gradient of the tangent. Okay, so now it says determine the largest value of k such that 3 to the power of k is a factor of this product. Now, basically what you have to do is, the question is asking you how many 3's to some power do you have in 1 times 2 times 3 times da 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 all the way to 30. So you start off and you look for the multiples of 3 that you've got in that 1 times 2 times 3 da 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 da. So it's 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Those are the multiples of 3. And now you look at those and you kind of put them into their, what do you call it? Prime numbers, prime factors. Thanks. So 3 is just 3, but 6 you can make 3 times 2. 9 is 3 squared. 12 is 3 times 2 squared. That is, this is 3 squared times 2. 21 is 3 times 7. 24 is 3 times 8. 27 is 3 cubed, and 30 is 3 times 10. And then you count them all. So that is 3 to the 1, 3 to the 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 3 is 12, 13. I missed one somewhere. It's 14. Yeah, it's 14. So it's 3 to the power of 14. So K is 14. Okay. But really, problem-solving type question that if you don't know what to do straight away, you leave till the end and come back to. It's 3 marks, so 3 minutes. And if you can't get it in 3 minutes, you move on to more important things. Okay. Last one I think we have time for is if n is the largest integer for which n to the power of 200 is smaller than 5 to the power of 300, determine the value of n. Okay, now always with exponents, you can't do anything unless you're looking at something that looks the same. So let's break this up and let's make this n to the power of 2 to the power of 100. And then let's make this 5 to the power of 3 to the power of 100. Because we've got the 200 and the 300, so we can use this power rule to make it 2 times 100 will give me 200, and 3 times 100 will give me 300. Okay, now we can take the 100th root, if there's such a thing, which there is, 100th root on both sides. And you left, now it becomes much easier because you left with n squared is 5 to the power of 3. You've taken the 100th root, so the 100 is gone away. So n squared is 5 to the power of 3, which you can actually just make 125. And now it's much easier because you can take a square root. And then n comes to 11 comma something. But it says, what is the largest integer for which n to the power of 200 will be smaller than 5 to the power of 300? So the largest, we can't round up, we have to round down. So n must be 11 because it has to be an integer. Okay, also 3 mark problem-solving question that you don't spend more than 3 minutes on. If you can't get it, move on to more important things. Okay, Asipe, how's that? That was your question as well. Both of these were yours. No, don't be. It's not easy. That first one was definitely something that made me think a lot. And this second one, you also have to, thing is, you have to just, doubts cleared. Perfect. I'm so happy to hear that. But just with these questions, you have to sort of play around a little bit. Just start something, just try something. Remember on Monday, we also had that graph question where we were all a bit like, we don't know what to do. So just play around with it. But because you're in an exam, you only have 3 minutes to play and then you have to move on. So Okay, Timothy, you also submitted 2 more questions. Our time is up, so I'm gonna leave them for Monday. Unfortunately, it's a while before. Actually, what I'll do is I did write down the answers, so I'll put the answers up. Unless you guys don't mind to see the top one again. Okay, unless you guys don't mind to stay 5 extra minutes, then we can do these last 2 questions. Okay, so Jaden, you want to see that one? Okay, I'll put it back up at the end. Let's just try and get through Timothy's question over here, because it is paper 1 and sounds like paper 1 is happening on Friday. Okay, so we are going to, first of all, put everything over a square root, because you are multiplying a square root with a square root. So you can just make it simpler and put everything over a square root and then square both sides. And then you're left with this root 32 plus x and root 32 minus x, which is just a very well disguised difference of 2 squares, because root 32 times root 32 is going to give you 32, and then plus x minus x gives you x squared. You can FOIL it out. You will get to that same thing, 32 minus x squared. Add on both sides. X on both sides. Solve for x. X is positive or negative. Don't forget that if you take a square root, it is always positive or negative. Okay, so Timothy, that was your first one. Then this one, 2 to the x times 3x plus 1 must be smaller than 0. Now, the thing is, 2 to the x is always going to be positive, because that is a power. It's always going to be positive. Something to a power is always positive. It just gets bigger and bigger. It's an exponent. That means we must look where 3x plus 1 is negative. So I drew a little graph here. That is the graph of 3x plus 1 over here. So we want to see where the graph is negative, and that is where x is smaller than negative 1. Because a negative and a positive and a negative is going to give you a negative overall, and that's what we're looking for. It has to be negative. It has to be smaller than 0. So x is smaller than negative 1 over 3. How's that, Timothy? Seems simple when I do it. Okay, let's put this back up for Jaden. You're most welcome, Timothy, anytime. Okay. Jaden, there's that first one again with the powers and the factors. Okay, thanks everyone. I think we've gone over time, but I think it was worth it. If you're writing on Friday, so much good luck to you, and get enough sleep. Don't burn the candle on both ends. Get enough sleep so that you're fresh. And next week we're back here again, Monday and Wednesday, for Q&A. So I look forward to your questions. Please email them to me or put them on the chat in the app. I'll get them. Thank you so much, guys, and good luck, and see you Monday again, hopefully. Bye.